so analyzing functions. We're going to analyze functions represented in different ways, including tables, equations, and graphs. So right off the bat, you should recognize this is going to be a linear function because x is to the power of 1. And if you think back to algebra 1, y equals mx plus b, we have our y-intercept and we have our slope. Now, although we could graph this just for that information, we are learning how to create tables based on this information. So I'm going to put numbers in for x, but I'm going to choose even numbers because that way I get half of an even number and I don't have to worry about any decimals and it's easier to graph that way. So I'm going to do -4, -2, 0, 2, and 4. And all I'm going to do here is I'm going to plug it in. 1/2 of -4 minus 5. Well, half of -4 is -2 minus 5 is -7. 1/2 of -2 minus 5, that's -1. Minus 5 is -6. Half of 0 is 0. Minus 5 is -5. Half of 2 is 1. Minus 5 is -4. And you can kind of see where this is going. Half of 4 minus 5, -3. And we plug these in, or plot them, -4, -7, -2, -6, 0, -5, 2, -4, and 4, -3. Which, if you look at this, there's our y-intercept, and it does have a slope of up 1, right 2, up 1, right 2. So where's the next point going to be? Up 1, right 2, 6, -2, and so forth. Now, what type of block is it? It's linear. The domain is going to go left and right forever and ever, and it's going to go up, down, and up forever and ever. Absolute value. I'm just going to put the numbers in, -2, -1, 0, 1, 2. Now, if you think about it, just remind yourself, you don't have to draw this, but remember what our initial absolute value looked like. It looked like that. So let's see how this one is going to look compared to that. So we're going to do the absolute value of -2 minus 1 minus 4. So -2 minus 1 is -3. And absolute value of -3 is 3. Minus 4 is -1. Absolute value of -1 minus 1 minus 4. That's -2. Absolute value is 2 minus 4 is -2. 0 minus 1 minus 4. That's -1. Absolute value is 1 minus 4 is -3. 1 minus 1 is 0. Absolute value is 0 is 0. Minus 4 is -4. 2 minus 1 minus 4. 2 minus 1 is 1. Absolute value is 1. Minus 4 is -3. Let's look what happened with 3. Hopefully you see a pattern going. 3 minus 1 minus 4. 3 minus 1 is 2. Absolute value of 2 is 2. Minus 4 is -2. Hopefully you can see this and try and figure out what the next number would be if we plugged in 4. So, -2, -1. -1, -2. 0, -3. 1, -4. 2, -3. And 3, -2. And where do we say the next one should be? 4, -1. You betcha. So there's that same b, but you can see that it just is dropped down and over one space. It's dropped down 4 and over 1. So this is absolute value, because it's got the V shape. The domain, how far left? It's going to keep going. How far right? It's going to keep going. Now the range, how low does it go? It hits at -4. Bracket, because it is actually touching there. And then how high does it go? Forever. Okay, here we have a quadratic. How do we know that? Because of this 2 right here. So -2, -1, 0, 1, 2. I'm going to do -2 squared minus 3, -1 squared minus 3, 0 squared minus 3, 1 squared minus 3, and 2 squared minus 3. -2 times -2 times -2 is -8. Minus 3 is -11. -1, I'm sorry, I cubed it, my bad. -2 squared, that seemed wrong. -2 squared is 4, minus 3 is 1. -1 squared is 1, minus 3 is -2. 0 squared is 0, minus 3 is -3. 1 minus 3, again, -2, and 4 minus 3, again, is 1. So, -2, and remember where our parabola the other day was? It was something like that. Let's see what happens to this one. -2, 1, -1, -2, 0, -3, 1, -2, and 2, 1. Notice that there are mirror images left and right. And there's my parabola. It just dropped down 3 spaces. So what's my domain? Again, it's going to keep going left and right forever. My range, how low does it go? Well, it starts at -3, so I use a bracket and parentheses for the infinity. Okay? 4. Now I have 2 to the x. That's exponential. So I'm going to use, -1, 0, 1, 2, 3. So again, 2 to the -1 minus 3. Remember, 2 to the -1 is really just 1 over 2 to the 1, 1/2. So that's 0.5. But 0.5 minus 3 is -2.5. Then we have 2 to the 0, which is 1. Minus 3 is -2. And then 2 to the 1, which is 2, minus 3 is 1. -1, sorry. And then we have 2 squared minus 3, which is 4 minus 3, which is +1. And we have 2 cubed minus 3, that's 8 minus 3, which is 5. So we're going to pop these over here, -1, -2.5. Between 0, -2, 1, -1, 2, 1, and 3, 5. And if you kept going on the negative side, you would see that this would never hit this line, -3. And remember, the other day, when we drew this, it looked like this. Now it's the same thing, just drop down, and instead of never hitting 0, it's never going to hit -3. So my domain is left and right forever, negative, positive, infinity. My range, how low does it go? -3, but it never touches, so we use parentheses, and here we use positive infinity for the upward direction. Okay, now this time we have 0.5 to the x, which is also exponential. Okay, So this one up here is growth. We don't need to specify that much right now. But we have two exponentials. We'll talk about this as effect. So now we have 0.5 raised to the x plus 1. So if you think about what this looked like the other day, we'll talk about that. We'll go from there. So I'm going to start at -3, -2, -1, 0, 1. So 0.5 to the -3. Well, so 0.5 to the -3rd, remember that's 1/2 to the -3rd. So if you did 1/2 times 1/2 times 1/2, you get 1/8. But remember, we have to flip it, so it's 8/1. And then plus 1 would be 9. And then we have 0.5 squared. Well, once again, remember, we're going to flip it, I'm sorry, to the -2. So remember, we're going to flip that. So instead of being 1/2 times 1/2, that's going to be 2 times 2, which is 4, plus 1 is 5. Then we use -1, 0.5 to the -1. That's, remember, 0.5 to the 1 is 1/2. Flip it, that's 2, plus 1 is 3. Then 0.5 to the 0, anything to 0 is 1, plus 1 is 2. And then 0.5 to the 1, the first power is 0.5, plus 1 is 1.5. So, -3, 9, -2, 5, -1, 3, 0, 2, 1, 1.5, and so forth. And we can, if we kept going with this, we would see that it's never going to hit the number 1. Like we heard the other day, our graph looked just very similar, but it was generally right about here. This time it's never going to hit the 1. So what's my domain? Again, it's going to go left and right forever. How low is it going to go? 1, but it's not going to hit it, so we use the parentheses, and upwards towards positive infinity. Okay, square root of a number plus 1. So I'm going to, again, I can't use negatives, we can't use square root of negative. So I'm going to start with 0 and use 4 and 9. Because the square root of 0 is 0, plus 1 is 1. The square root of 4 is 2, plus 1 is 3. And the square root of 9 is 3, plus 1 is 4. And I can't really do the square root of 16 on here because it only goes to 10, so we're just going to stop there. When we had a bigger graph, we could use 16, which would be 16/5. And if we had a bigger graph, 25, square root of 25 is 5, plus 1 is 6. So, 0, 1, 4, 3, and 9, 4. Remember, the other day when we started with this basic one, our parent function was like this. Now it's just a little bit higher. It's moved up one space. So, what is this? This is a square root function. The domain is how far left does it go? Well, it does start at 0, so we use a bracket. And it goes right forever. How low does it go? It starts at 1. Bracket, and goes up towards positive infinity. Parentheses. first, absolute value. X to the 1, linear. Exponent right there. Now since this here is a fraction, that is decay. This little 2 means quadratic. Obviously the square root symbol. And here, an exponent, a whole number larger than 1, which means this is exponential growth. Notice both of these are exponential because they have exponents up there. We're taking a number or a number to an exponent. That's where our x is. The x is in the exponent spot. Okay, so what do these look like? Well, here we have decay. Because over time it's going down. Here we have v for absolute value. Here we have a linear function, straight line. Here we have square root. Here we have exponential growth. It's going up over time. And here we have a parabola, which means it is quadratic. Okay, let's get through this last part. Now we're looking at a table. We can actually identify what's going on based on how the table is changing. So you can test whether a function is linear by finding the difference between the consecutive y values. If the first differences are all equal, the function is linear. So notice how this is changing, 8.1 plus 8.1 plus 8.1 plus 8.1. Since it's changing exactly the same way, it's a linear function. Now, what if they're not the same? Like here, we go up 18, then we go up 22, then 26, then 30. What we do then is we look at the second difference. Okay? And notice that, yeah, it goes up 18, then 22, then 26, then 30. But the second difference is plus 4, plus 4, plus 4. So the second time around, it's going up by 4. That makes it a quadratic function. So let's look quickly at these right here. Remember, f of x is y. So all we're going to do is, real quickly, we're just going to do 243 minus 192. And this went up plus 51. And 192 minus 147. And that's plus 45. And then 147 minus 108. Well, that was plus 39. And 108 minus 75 is plus 33. So obviously, that is not a linear function because the first difference is different. But look what happens here. Plus 6, plus 6, plus 6. The second is the same, making it quadratic. Okay, now sometimes it doesn't go up by plus, it might go up by times, which is called a common ratio. So if that's the case, if the ratios are all equal, it's exponential. So notice here, they're going up, it's plus 10, then plus 30. Like, let's say you did that. You probably would look at this and go, oh, well, it went up plus 10, then 30, and then 90, and so, wow, it's huge. And then obviously the difference between plus 10 and plus 30 and plus 90 are not, on the second level, well, that's plus 20 and that's plus 60. No, can't be linear and can't be quadratic. At that point, you have to look at it and see if it's going up by multiplication, which in this case it is. 5 times 15, 5 times 3 is 15, times 3 times 3 times 3. That makes it exponential. So we're almost finished here. looking at this is going up plus 2. Don't write this down. Then plus 6. Then plus 18. And plus a whole lot more, actually 54. Well, obviously not linear. Then from 2 to 6 is 4, and then 12, and it's obviously not quadratic. So let's look at it again. 1 times 3 times 3 is 9, times 3 is 27, times 3 is 81. Exponential. Negative 12 to negative 8, that's plus 4, plus 4, plus 4, plus 4. That makes it linear. And now we are finished.